The igniters on the gas cooktop are being inadvertently energized when the furnace air handler is turned on. This suggests that the electrical circuit wiring for the cooktop and the furnace air handler may be interconnected or influenced by each other. There are several possible causes. Firstly, loose or defective neutral connections. Neutral wires in electrical circuits provide the return path for current. Loose or defective neutral connections can create voltage fluctuations that can cause other devices on the circuit to behave erratically. Secondly, ground faults. Ground faults occur when an electrical current unintentionally flows through a path other than the design circuit. This can result in voltage fluctuations and equipment malfunctions. Thirdly, cross-wiring. Electrical wires may have been inadvertently crossed, connecting the cooktop and furnace air handler circuits. This would allow current to flow from the furnace air handler to the cooktop, causing the igniters to activate. Fourthly, inductive interference. Electromagnetic fields generated by the furnace air handler motor or other components can induce voltage spikes in the cooktop circuit, triggering the igniters. Here are some troubleshooting steps. 1. Check neutral connections. Ensure that the neutral wires at the cooktop, furnace air handler, and circuit breaker panel are securely tightened and free of damage. 2. Test for ground faults. Use a voltage tester or multimeter to check for ground faults by measuring the voltage between the neutral wire and the ground wire. Any significant voltage indicates a ground fault. 3. Inspect wiring. Trace the electrical wires from the cooktop and furnace air handler to the circuit breaker panel to check for crossed or damaged wires. 4. Test for inductive interference. Temporarily disconnect the furnace air handler from the electrical circuit. If the igniters stop activating when the furnace air handler is disconnected, it may suggest inductive interference. 5. Consider circuit separation. If the problem persists, consider separating the cooktop and furnace air handler circuits by installing them on different circuit breakers or using electrical isolators. When dealing with electrical issues, safety is paramount. Working with electricity can be dangerous, and it's crucial to take precautions to protect yourself and prevent damage to your property. Firstly, always disconnect power. Before you start any electrical work, always turn off the power to the circuit you'll be working on at the circuit breaker panel. This will help prevent electrical shock. Use a voltage tester to confirm that the power is off before you touch any wires. Secondly, use insulated tools. Use tools with insulated handles to protect yourself from electrical shock. Avoid using tools with metal handles, as they can conduct electricity. Thirdly, wear safety glasses. Wear safety glasses to protect your eyes from flying debris or sparks. Electrical work can sometimes generate sparks, so it's important to protect your eyes. Fourthly, work in a dry area. Avoid working in damp or wet areas, as water can conduct electricity. If you must work in a damp area, use a ground fault circuit interrupter or GFCI to protect yourself from electrical shock. Fifthly, know your limits. If you're not comfortable working with electricity, or if you're unsure about any aspect of the job, it's best to call a qualified electrician. Electricians have the training and experience to safely and effectively handle electrical work. Grounding is a critical safety measure in electrical systems. It provides a low impedance path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and prevent electrical shock. Here are some key aspects of grounding. Firstly, grounding electrode system. The grounding electrode system is the foundation of the grounding system. It typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal underground water pipes that are connected to the earth. The grounding electrode system provides a low resistance connection to the earth, which helps to dissipate fault current. Secondly, equipment grounding conductor. The equipment grounding conductor, or EG, is a wire that connects the metal parts of electrical equipment such as appliances, tools, and enclosures to the grounding electrode system. The EGC provides a path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and prevent electrical shock. Thirdly, bonding. Bonding is the process of connecting all metal parts of an electrical system together to create a continuous electrical path. This helps to ensure that all metal parts are at the same potential, which reduces the risk of electrical shock. Bonding is typically accomplished by using bonding jumpers, which are short lengths of wire that connect metal parts together. Fourthly, ground fault circuit interrupters. Ground fault circuit interrupters, or GFCIs, are devices that detect ground faults and quickly interrupt the flow of electricity. GFCIs are designed to protect people from electrical shock, and they are required in many locations, such as bathrooms, kitchens, and outdoor areas. Fifthly, importance of proper grounding. Proper grounding is essential for electrical safety. It helps to prevent electrical shock, reduce the risk of fire, and protect electrical equipment from damage. If you're not sure about the grounding system in your home or building, it's best to consult with a qualified electrician. Electrical codes and standards are sets of rules and regulations that govern the design, installation, and maintenance of electrical systems. These codes and standards are developed by organizations such as the National Fire Protection Association, or NFPA, and the Institute of Electrical and Electronics Engineers, or IEE. Electrical codes and standards are designed to ensure electrical safety and prevent electrical hazards. Firstly, National Electrical Code. The National Electrical Code, or NEC, is the most widely adopted electrical code in the United States. The NEC is developed by the National Fire Protection Association, and it is updated every 3 years. The NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Secondly, importance of following electrical codes. Following electrical codes is essential for electrical safety. The electrical codes are designed to protect people from electrical shock, reduce the risk of fire, and protect electrical equipment from damage. When you're working with electricity, it's important to be aware of the electrical codes that apply to your area. Thirdly, local amendments. Local jurisdictions may adopt amendments to the NEC to address local conditions or concerns. It's important to be aware of any local amendments to the NEC that apply to your area. Fourthly, qualified electricians. Qualified electricians are trained and experienced in electrical codes and standards. They can ensure that electrical work is performed safely and in accordance with applicable codes. Fifthly, regular inspections. Regular electrical inspections can help to identify potential electrical hazards and ensure that electrical systems are in compliance with applicable codes. Overcurrent protection is a critical safety feature in electrical systems. It protects electrical circuits and equipment from damage caused by excessive current flow, such as short circuits and overloads. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of electricity when the current exceeds a safe level. Firstly, circuit breakers. Circuit breakers are devices that automatically interrupt the flow of electricity when the current exceeds a safe level. Circuit breakers can be reset after they trip, which makes them a convenient option for overcurrent protection. Secondly, fuses. Fuses are devices that contain a metal strip that melts and breaks the circuit when the current exceeds a safe level. Fuses must be replaced after they blow, which can be inconvenient. Thirdly, types of overcurrent protection. There are two main types of overcurrent protection: time delay and instantaneous. Time delay overcurrent protection devices are designed to allow a certain amount of overcurrent to flow for a short period of time before interrupting the circuit. This type of overcurrent protection is often used for motor circuits, where the motor may draw a large amount of current when it starts up. Instantaneous overcurrent protection devices are designed to interrupt the circuit immediately when the current exceeds a safe level. This type of overcurrent protection is often used for circuits that feed sensitive electronic equipment. Fourthly, selecting the correct overcurrent protection device. Selecting the correct overcurrent protection device is essential for electrical safety. The overcurrent protection device must be sized to protect the circuit and equipment that it is feeding. The size of the overcurrent protection device is determined by the ampacity of the conductors in the circuit. Fifthly, importance of overcurrent protection. Overcurrent protection is essential for electrical safety. It helps to prevent electrical shock, reduce the risk of fire, and protect electrical equipment from damage. If you are not sure about the overcurrent protection in your home or building, it's best to consult with a qualified electrician. Wiring methods refer to the different ways that electrical wires are installed and protected. The choice of wiring method depends on the application, the environment, and the applicable electrical codes. Firstly, non-metallic sheath cable. Non-metallic sheath cable, or NM cable, is a type of electrical wiring that consists of two or more insulated conductors enclosed in a non-metallic sheath. NM cable is commonly used for residential wiring. Secondly, metallic conduit. Metallic conduit is a type of electrical raceway that is made of metal. Metallic conduit provides a high level of protection for electrical wires. There are several different types of metallic conduit, including rigid metal conduit, intermediate metal conduit, and electrical metallic tubing. Thirdly, flexible metal conduit. Flexible metal conduit is a type of electrical raceway that is made of flexible metal. Flexible metal conduit is often used in applications where the wiring needs to be flexible or where it is difficult to install rigid conduit. Fourthly, cable trays. Cable trays are a type of support system for electrical cables. Cable trays are often used in industrial and commercial applications where there are a large number of cables. Fifthly, wiring in hazardous locations. Wiring in hazardous locations requires special wiring methods to prevent explosions and fires. Hazardous locations are areas where there is a risk of flammable gases, vapors, or dust. Sixthly, importance of proper wiring methods. Proper wiring methods are essential for electrical safety. They help to protect electrical wires from damage, prevent electrical shock, and reduce the risk of fire. If you're not sure about the wiring methods in your home or building, it's best to consult with a qualified electrician. Electrical panels, also known as circuit breaker panels or load centers, are the main distribution points for electricity in a building. They receive power from the utility company and distribute it to individual circuits throughout the building. Electrical panels contain circuit breakers or fuses that protect each circuit from overcurrents. Firstly, components of an electrical panel. An electrical panel typically includes the following components: a main breaker, which disconnects all power to the panel, circuit breakers or fuses, which protect individual circuits, a bus bar, which distributes power to the circuit breakers, and a neutral bar, which provides a return path for current. Secondly, types of electrical panels. There are two main types of electrical panels: main panels and subpanels. Main panels are the primary distribution points for electricity in a building. Subpanels are used to distribute power to specific areas or equipment. Thirdly, sizing an electrical panel. The size of an electrical panel is determined by the total electrical load of the building. The electrical load is the amount of power that is required to operate all of the electrical devices and equipment in the building. Fourthly, replacing an electrical panel. Replacing an electrical panel is a complex and potentially dangerous task. It is important to hire a qualified electrician to replace an electrical panel. Fifthly, importance of proper electrical panels. Proper electrical panels are essential for electrical safety. They help to protect electrical circuits from overcurrents, prevent electrical shock, and reduce the risk of fire. If you are not sure about the electrical panel in your home or building, it's best to consult with a qualified electrician. Multi-wire branch circuits are a type of electrical circuit that shares a common neutral conductor. Multi-wire branch circuits are often used to save money on wiring costs and to reduce the amount of conduit that is required. Firstly, how multi-wire branch circuits work. A multi-wire branch circuit typically consists of two hot conductors and a neutral conductor. The two hot conductors are connected to different phases of the electrical supply, which are typically 120 volts each. The neutral conductor provides a return path for current from both hot conductors. Secondly, benefits of multi-wire branch circuits. Multi-wire branch circuits offer several benefits. Firstly, they can save money on wiring costs, as only one neutral conductor is required for two hot conductors. Secondly, they can reduce the amount of conduit that is required, as only 3 conductors are required instead of 4. Thirdly, they can improve voltage stability, as the neutral conductor is shared between 2 hot conductors. Thirdly, safety considerations for multi-wire branch circuits. Multi-wire branch circuits can be dangerous if they are not wired correctly. It is important to ensure that the neutral conductor is properly sized to handle the current from both hot conductors. It is also important to ensure that the circuit breakers for the 2 hot conductors are connected to different phases of the electrical supply. Fourthly, common applications for multi-wire branch circuits. Multi-wire branch circuits are commonly used in residential and commercial buildings to power lighting, receptacles, and small appliances. They are also used in industrial applications to power motors and other equipment. Fifthly, importance of proper multi-wire branch circuits. Proper multi-wire branch circuits are essential for electrical safety. They help to prevent electrical shock, reduce the risk of fire, and protect electrical equipment from damage. If you're not sure about the multi-wire branch circuits in your home or building, it's best to consult with a qualified electrician. Inductive interference is a phenomenon that occurs when the electromagnetic field from one electrical circuit induces a voltage in another electrical circuit. This can cause problems such as noise, distortion, and malfunctions in electrical equipment. Firstly, causes of inductive interference. Inductive interference is caused by the electromagnetic field that is generated by electrical current flowing through a conductor. The strength of the electromagnetic field depends on the amount of current flowing through the conductor and the distance from the conductor. Secondly, effects of inductive interference. Inductive interference can cause a variety of problems in electrical equipment. It can cause noise and distortion in audio and video signals, malfunctions in electronic devices, and even damage to electrical equipment. Thirdly, reducing inductive interference. There are several ways to reduce inductive interference. Firstly, shielding. Shielding involves enclosing electrical circuits in a conductive material such as metal to block electromagnetic fields. Secondly, grounding. Grounding involves connecting electrical circuits to the earth to provide a path for stray currents to flow. Thirdly, filtering. Filtering involves using electronic circuits to remove unwanted frequencies from electrical signals. Fourthly, separation. Separation involves keeping electrical circuits that are susceptible to inductive interference away from electrical circuits that generate electromagnetic fields. Fourthly, common examples of inductive interference. Inductive interference is a common problem in electrical systems. Here are some examples of inductive interference. Noise in audio equipment caused by nearby electrical wiring, distortion in video equipment caused by nearby electrical motors, malfunctions in electronic devices caused by nearby radio transmitters, and damage to electrical equipment caused by lightning strikes. Fifthly, importance of reducing inductive interference. Reducing inductive interference is essential for electrical safety and the proper operation of electrical equipment. If you're experiencing problems with inductive interference in your home or building, it's best to consult with a qualified electrician. When diagnosing electrical problems, a systematic approach is crucial for efficient and accurate troubleshooting. Here's a breakdown of a recommended methodology. Firstly, gather information. Collect as much information as possible about the problem. This includes the symptoms when the problem occurs, what equipment is affected, and any recent changes to the electrical system. Talk to the people who are experiencing the problem to get their perspective. Secondly, visual inspection. Perform a thorough visual inspection of the affected area. Look for any obvious signs of damage, such as frayed wires, loose connections, burned components, or water damage. Check for any unusual odors, such as burning plastic or electrical smells. Thirdly, testing. Use appropriate test equipment to measure voltage, current, resistance, and continuity. Verify that the power supply is functioning correctly and that the correct voltage is present at the affected equipment. Test for ground faults and short circuits. Fourthly, analysis. Analyze the data collected from the visual inspection and testing. Identify the most likely causes of the problem. Use your knowledge of electrical circuits and equipment to narrow down the possibilities. Fifthly, repair. Once you have identified the cause of the problem, make the necessary repairs. This may involve replacing damaged components, tightening loose connections, or rerouting wiring. Ensure that all repairs are done in accordance with applicable electrical codes and safety standards. Sixthly, verification. After making repairs, verify that the problem has been resolved. Test the affected equipment to ensure that it is functioning correctly. Monitor the system for any recurrence of the problem. Seventhly, documentation. Document all of your findings, tests, and repairs. This will help you to track the problem and to prevent it from recurring in the future. It will also be helpful for future troubleshooting. Electrical safety is a paramount concern when working with any electrical system. Always prioritize safety to prevent injuries, fires, and equipment damage. Firstly, de-energize circuits. Before working on any electrical circuit, always de-energize it by turning off the appropriate circuit breaker or switch. Use a voltage tester to verify that the circuit is de-energized before touching any wires or components. Secondly, use personal protective equipment. Wear appropriate personal protective equipment or PPE such as safety glasses, rubber gloves, and insulated tools. This will help to protect you from electrical shock, burns, and other injuries. Thirdly, follow lockout-tagout procedures. Follow lockout-tagout procedures to ensure that circuits remain de-energized while you are working on them. This involves placing a lock and tag on the circuit breaker or switch to prevent it from being turned on accidentally. Fourthly, work in dry conditions. Avoid working on electrical circuits in wet or damp conditions. Water can conduct electricity and increase the risk of electrical shock. Fifthly, know your limits. If you are not comfortable working on electrical circuits, or if you are not sure how to do something safely, do not attempt it. Call a qualified electrician to perform the work. Sixthly, inspect tools and equipment. Regularly inspect your electrical tools and equipment for damage. Replace any damaged tools or equipment immediately. Seventhly, be aware of your surroundings. Be aware of your surroundings when working on electrical circuits. Watch out for overhead power lines, other electrical equipment, and potential hazards. Eighthly, use caution when working with capacitors. Capacitors can store electrical energy even after the circuit is de-energized. Use caution when working with capacitors to avoid electrical shock. Ninthly, follow electrical codes. Follow all applicable electrical codes and regulations. These codes are designed to ensure electrical safety and prevent electrical hazards. Tenthly, call for help if needed. If you are ever unsure about something, or if you encounter a problem that you cannot solve, call for help from a qualified electrician. Consulting a qualified electrician is crucial in many electrical situations, ensuring safety, code compliance, and proper system operation. Here are some scenarios when professional help is highly recommended. Firstly, complex troubleshooting. When dealing with complex electrical problems that you cannot diagnose or resolve yourself, a qualified electrician has the expertise and tools to identify the root cause and implement effective solutions. Secondly, major electrical work. For significant electrical projects such as wiring a new addition, installing a new electrical panel, or upgrading your service, hiring a qualified electrician is essential to ensure safety and code compliance. Thirdly, unfamiliar electrical systems. If you are working with an unfamiliar electrical system, such as in a new home or building, consulting a qualified electrician can help you understand the system and avoid potential hazards. Fourthly, code compliance concerns. Electrical codes are constantly evolving, and it can be difficult to stay up to date. A qualified electrician can ensure that your electrical work complies with all applicable codes and regulations. Fifthly, safety concerns. If you have any safety concerns about your electrical system, such as flickering lights, sparking outlets, or unusual odors, contact a qualified electrician immediately. Sixthly, selling or buying a home. Before selling or buying a home, it is a good idea to have the electrical system inspected by a qualified electrician. This can help to identify any potential problems and ensure that the system is safe and up to code. Seventhly, insurance requirements. Some insurance companies may require that certain electrical work be performed by a qualified electrician. Eighthly, when in doubt. If you are ever in doubt about whether or not you can safely perform electrical work, it is always best to err on the side of caution and call a qualified electrician.